That is looking good. Setting up. Here we go. And I'm sharing the link over there, today's paper. Here we Fantastic. Victor needs the link as well. Hey, Victor.
Hi, good morning.
Good morning. Welcome to Neuroccino. So for those of you who follow us on a regular basis, which applies to most of you in this room, you know that we discussed the conundrum papers a couple of weeks ago. Sorry, talking and typing. We discussed the conundrum papers a while ago, and that was a debate between Mizolam and a group from South Carolina around Matin. And from this debate, we now have a second debate, because I briefly showed the paper that we published in Neurology in 2020, where we showed that repetition in the brain relies mainly on the indirect segments connecting to the inferior parietal lobe in patients with primary progressive aphasia. And today I'm going to present a paper that actually demonstrated it's the long segment of the arcuate, and we have the senior author amongst us as well, so hopefully we should have some nice discussions. Hi, Adi. Now let me share the screen so you can see it. Okay, so this is the paper. I shared the link with you in the chat and over on YouTube. And basically in this paper, they had a wonderful amount of healthy volunteers, namely 50 healthy volunteers who participated in the study. The age range was 19 to 75 years. And what they did in this paper is they looked at the long segment only, but two branches within the long segment. So one branch that goes to the superior temporal gyrus, the posterior part of the superior temporal gyrus, and one branch that goes to the middle temporal gyrus. And they probed those connections with probabilistic diffusion-weighted imaging, tractography, and also performed a functional imaging task where the participants had to do two tasks in the scanner. One was the repetition of pseudowords that they could hear, and the other one was generating a verb based on a noun they could hear. Now, the auditory input was from a female speaker only, and what they found then was that the reaction time was higher for verb generation based on the noun, which I'm sure we're going to tap into a little bit in the following discussions. Now, from that, they extracted the peak activations of the fMRI task for the frontal and the temporal regions and put a 6 millimeter sphere around that, and then used that as a seed region for the diffusion tractography. Now, what's important to know is that the diffusion was limited by an exclusion region of the cerebrospinal fluid mask, but also the external extreme capsule to avoid picking up the ventral stream. There is some normalization to MNI involved, obviously, to make all of this happen, and I can show you. Oh yeah, and then the result, sorry, I should mention that as well. The result was that the branch that connects to the superior temporal gyrus is relevant for repetition of pseudowords, so tapping into the sublexical phonological mapping of language, whereas the superior temporal gyrus connection to frontal was relevant for verb generation, tapping into the lexical-semantic. Now, in terms of what the results look like, here you see the fMRI. It was a block design, auditory stimulation from either side. And the results look like this. So here we have the activation from the fMRI study. Blue is the repetition, red is the verb generation. We can already see there's quite an extended network of activation on the lateral surface, but you can also see the axial slices across the volume. And then for the diffusion imaging, they identified those peak activation areas. So in green and the frontal lobe, we have both paths that are activated, which looks like the ventral premotor area, subcentral cortex here. So just posterior to classical Broca's area. And in the temporal, we have the posterior superior temporal gyrus region. That was the peak activation for the pseudoword repetition. And then we have the middle temporal gyrus activation that peaked for verb generation and was used as a seed. So these are the seeding areas for the tractography. And then, no surprise, what we get from probabilistic tractography is from the seed region in the STG, we have a connection to the frontal lobe, and from the seed region in the MTG, we have a connection to the frontal lobe, and we don't see anything going ventral because I mentioned that they excluded the external extreme capsule. And then here you see the sagittal and coronal slices through the probabilistic tracking. They then also did some further analysis to show the specificity of these results and the separation between the two tasks, and also looked at the reconstruction for the external extreme fiber pathway, so the ventral pathway, and probabilistic tracking revealed this connection, but they also highlight that this tract does not look like the traditional ventral pathway, possibly because the tractography is artificially being forced not to use the dorsal route in this case, and I would definitely agree with that. And we know that if we have seed and target, we always get a reconstruction with probabilistic. So this is probably to be interpreted a little bit cautiously. That is a very brief run through of this paper. In comparison, for those of you who were not here when we discussed the conundrum, the paper that is in contrast, if you want to say that, is this one where we looked at the indirect pathway for repetition. And what we found very briefly, we separated the arcuate into long anterior posterior, so looking at the stopover in the parietal lobe. And we found, here we go, that there was no correlation between repetition and the long segment, but a correlation between repetition and the indirect segment, in particular the posterior segment of the arcuate in patients. Now, there's a couple of differences between those two papers, and I briefly wrote them down, which you probably can't read. So the main differences is that one is probabilistic, one is deterministic tractography, one is looking at healthy controls, one is looking at patients. One uses functional seeds, whereas the other one uses anatomical regions of interest. Then we have confrontational naming versus generation of verbs. we have visual versus auditory stimuli, a different age range, slightly different anatomical separation of the arcuate fasciculus. So we looked at the 3 segments, whereas the study looked at subsections of the long segment. The study I just presented looked mainly at fractional anisotropy values, whereas we looked at volume. Then in terms of the behavioral measurement, the current study looked at reaction time, and we looked at words per minute and correct words. And then there's also a difference between normalization to MNI and native space. This is just a brief run through and a couple of differences that I pulled out looking at the 2 studies. And I'm happy to dive into the discussion. Any questions? No question? Well, in that case, let me ask Adi. So you, thanks for sending the paper and bringing it to my attention. I think you had a couple of discussion points. Anything you want to add to the brief presentation of your paper?
Yeah, only there's one technical thing, namely, I think the modality is not different. So you said visual versus auditory, but we also used auditory stimuli for both tasks. So that's not different.
No, you used auditory, we used visual.
Visual in the repetition task? No, it was the web repetition task that you use.
Yeah, no, you're right. Yeah.
Yeah,
right.
So that is modality is not a difference. Yeah. So what triggered me contacting you was the of course you can think there is an empirical discrepancy, but perhaps not. The studies differ in several respects. But certainly there is a theoretical clash. So your interpretation is clearly different from our interpretation. So if you look at the empirical, of course, all kinds of smaller technical differences that you pointed at. They could be relevant, perhaps they are not. For me, if you look at, so you used patients with, you tested patients with PPA, primary progressive aphasia. These patients have, as far as I know the literature, typically no problem with repeating words, but they have trouble repeating multi-word utterances. And the longer, the more difficult it is for them, especially the logopenic subgroup. You used also a test, the web repetition, that is sort of biased towards the multi-word repetition. So perhaps I should do one step back, namely the distinction that Shellis and Warrington made several years ago. That's also what you mentioned in your paper as a sort of a framework for interpreting your data. So that's already back in 77, time ago. They looked at the literature and there were many discrepancies, and they said, well, one salient thing that differs between studies is the materials used for testing repetition in patients, namely that ranges from single phonemes, words, up to complicated long sentences. And they made a distinction that you also made in your paper in discussing your findings, namely the reproduction patients, so to say, the patients have trouble with repeating, say, words, but then complicated words, multisyllabic words, versus the patients that have a short-term memory problem. That is, if you give them multi-word utterances, sentences, they have especially difficulty with that. Of course, typically, unless well, it also depends on the test that you used for determining whether the patient has a repetition problem. But typically, you will have a mixture of patients. Some are more towards the reproduction, the others are more towards the short-term memory difficulties. I would think repetition requires both the long and the indirect segments. Your patient group, they were tested using the web, so the items were biased, so to say, towards the STM route, taxing the STM route. So no surprise, given also that these patients typically do not have the arcuate much damage. Also, you find no difference between the patients and the control group in terms of the long segment. The long segment. So you have a patient group that has typically trouble with multi-word entrances. That's also the web test that you used for determining their performance on repetition tasks. The long segment is not really affected. So ideally, so the ideal situation of picking up the STM difficulty, and that is also what you say in your paper. In our situation, of course, we had healthy participants. We used items that would tax the content, the long segment as I would take it to be. So, and because we had polysyllabic pseudowords that we used for testing their performance. And indeed, we found the dependence on the different subtracts of the long segment. So the repetition of the pseudowords, the STG track, and the verb generation, the MTG subtract. So I would think if you look at both studies, then does not need to be a discrepancy, except when you think in terms of your theoretical interpretation, namely that repetition is done via the indirect pathway, and that both the reproduction and the STM patients sort of come out of the impairment of this pathway. So you say the posterior segment impairment leads to the STM, the short-term memory difficulty, and the anterior segment leads to the reproduction impairment. My interpretation is the long segment, that's the content pathway, should lead, if it's impaired, it would lead to the reproduction, and the indirect pathway leads to the STM difficulty. So I think here is the difference, the discrepancy in the interpretation, not necessarily in terms of the data. So if there's one more study I think I should mention, and then I stop. It's a long and complicated story. Sorry for that. There is an interesting study by Kummerer et al. They tested 100 stroke patients, and this is the Sauer-Kummerer group, and they've observed, and they tested the patients on a task that is sort of the opposite, having the opposite bias from the web repetition task, namely the Aachen repetition task, which is biased towards single words that are complicated in terms of content, multisyllabic, and they observed that the long segment damage predicted highly correlated with the repetition performance. So the long segment is involved with repetition, but you need to have a task, I think, that specifically taxes the long segment, which is the pseudoword of the low frequency polysyllabic items. Long story, sorry for that. I think theoretically there is a discrepancy, but empirically there need not be. If you look at the tasks or the materials that have been used and the biases that the tests have in them, and the patient group that you used for testing the contribution of the Arcuate.
No, I agree. Just 2 points I briefly want to make because I see there is a question. So I'm currently sharing the web repetition test. That you can see that we have individual words, and then it builds up to sentences to the end where we have a sentence that has all the letters of the alphabet, which was always my favorite. But the idea of the test design is that the span of the sentences is kept within the working memory span as well, to reduce the inference between working memory executive functions and language functions. And then the second point, another study that I also wanted to throw in is by Diana Lopez Barroso, who looked at word learning. Hang on, let me briefly show the paper. So this is the paper that I'm talking about. And here they also found the lung segment. There's also a combined fMRI tractography study. And word learning also relies on the lung segment in this study. And one could argue that learning words is also a auditory to motor mapping process. And in the beginning, any word is also a random string of letters, right, when you learn them afresh. So there is evidence that the long segment is implemented in repetition of some sort. That's all I wanted to throw in very quickly. There's a question from Patrick.
Yeah, thanks for this really interesting presentation, as well as the discussion already started with Ari. It kind of sounds to me as if the core problem is, or what makes the controversy to some degree, is to me an ill-defined definition of repetition, basically, because it appears as if there are simply different forms of repetition which are all just combined into this one bucket of a cognitive function named repetition, whereas it appears to me as if there are multiple facets that, depending on the direct stimulus and modality of the stimulus and art of stimuli, text basically different neurological substrates or submodes. So what do you think about that, basically? Because it aligns with what you're saying, if I understood you correctly.
Yeah, so that was basically my point or so. Once again, sorry for the complicated story, and that was the original point also of Shallis and Warrington. So the materials differ so much, and if you depending on what type of material you use, you get one type of outcomes or another type of outcomes. And yeah, so that's, I agree with your point.
But then isn't there much more need to go on to this theoretical level or perspective, and probably write something like a conclusive article on the different forms of repetition, so that we stop basically fighting about the neural substrates that determine repetition? If there are multiple things that are repetition, then...
Yeah, so I think it would be a very good idea if someone goes over the literature and carefully, so with this in mind, or as again taking to consider to take the framework of Shallis and Warrington, and then with an eye on differences in materials, you could take that as a starting point, go over the literature and try to see whether you can make sense of all the findings. Actually, that's what they did, and they had. So there was. So now we have all the evidence from all the sophisticated imaging techniques. They had that. That's not what they had available. So they had they had MRIs with very poor. Not even MRIs, CAT scans. I think they had. Yes, with very poor resolution, and we are now in a much better position to make sense of the data, I think. But somebody has to do it. I sort of very briefly hinted to Stephanie to do this together, to have a look at the literature to see whether we can make sense of this. It's a long. Actually, it's a long. The issue has a long history, going back to Wernicke's work, so 150 years ago. And it's still on the agenda. So I think it would be nice if we could somehow resolve it now.
But it's also a multi-level problem, right? Because we have differences in how we define repetition. That could be word repetition, sentence repetition, other kinds of repetition. Also, the fMRI tasks vary quite dramatically. So do the paper and pencil tasks, in terms of how we assess repetition, what the comparisons are in the data when we use a fMRI, but then also the anatomical level of how we define the cortical areas and the white matter also differs. So there's a lot to tackle in one go. But what I wanted to ask you, Adi, as well, looking at your paper, the Figure 1, where you showed the, hang on, let me share the screen so anyone can see what I'm talking about. So here we go, figure 1, you show the activation and the verb generation taps into a frontal temporal parietal network, which you would expect, right? So you presented auditorily a noun, and they had to generate a verb from the noun. So you would expect a semantic component in that specific task, let alone working memory, right? Just tapping into a new system now, which you don't necessarily need if you're just repeating pseudowords. Yet the semantic network, and this is nicely visible in this figure, depending on the authors that you ask, is either in the anterior temporal lobe or in the parietal lobe, which is quite far apart. So it's quite surprising to get such a divergence in results. And I think, personally, I think that the answer is the white matter, because that links those two distant areas. But given that you only find the dorsal connection, or find is the wrong word, you actually limited the analysis to the dorsal. I was wondering what your interpretation of the semantic network is.
Yeah, as you know, we have a model for this, and the model says, the model is called Weaver ++/ARC, and it has been applied to this type of data. Actually, last year I published a paper that applied the model to PPA, and there the claim is made that I followed the hub and spoke view. So we have a semantic hub in the anterior temporal lobes, and the spokes are the modality-specific semantic features, and these are, of course, in different areas of the brain. So I do not assign a special role to inferior parietal cortex as concerns semantic aspects of words. So unlike what Catani did, at least in one paper, or the old view of Cashwind, everything goes via the angular gyrus. Still, of course, we do find the angular, or it's angular gyrus inferior parietal activation, also in the repetition task, but that's of course not related to semantics, because we used pseudowords. So that's the only type of that's the only activation I not really can account for. So the other activations make sense. So the frontal, you need executive control indeed. The temporal cortex activations, semantic, retrieving dilemmas, as we call them. The parietal, I don't know. So what we did as a sort of a control test is to look whether the anterior segment of the indirect pathway that you also assessed contributes to the performance. So we reconstructed the SLF2 and 3 pathways, and the 3 is the, I think it corresponds with the anterior segment of the arcuate that you looked at. And we did not find any correlations with our repetition and our verb generation performance. Hence we concluded, well, it does not really contribute to the at least to the RT aspect of the performance. So that is my take on these activations. So the inferior parietal is a bit of a riddle, and that is relevant for certain theoretical interpretation. So what do you think, Stephanie? What might it be?
So in terms of the semantic network, the extended white matter of the language system actually correlates. So we often find the uncinate fasciculus, for example, that connects the inferior frontal and anterior temporal lobe. So to me, the fMRI activations that you see in figure 1 actually do make a lot of sense. And then I'm not entirely sure that we're going directly. So let's assume that the anterior temporal lobe is relevant for semantics. There might be 2 routes to propagate that information, feeding it back into the other processes related to language. And that doesn't necessarily have to be a direct connection from the MTG to the IFD via the Arcuate, for example. The parietal lobe is a consistent finding that comes up. And in fact, looking at your fMRI activations again, in our study with PPA, we also find this part here, the posterior supramarginal TPJ, even though I don't like that particular term, but the temporal-parietal junction area. So there is some overlap between the 2 data sets from your healthy controls and our patients. I'm a bit puzzled just looking at the figure by the non-word repetition just centering around the in-between your word generation activation. But
yeah, so the contrast were more activation in the one task versus the other. So it's relative in the sense that it could be that repetition also engages the angular or the more posterior part of the inferior parietal cortex, but the verb generation activates it more. Indeed, because it looks at where we found the verb generation activation is where you found that was the area perhaps where the atrophy contributed most to the repetition impairment in your study. Is that the case? What was it again? The temporal parietal junction.
The area that survived multiple comparison correction was here.
Yeah,
which is the posterior supramarginal gyrus TPJ area.
Yeah.
But then we also looked at inter-individual variability, and you can see that the pattern of cortical degeneration varies greatly between individual patients.
Yeah, I like that a lot. That was very instructive.
Patrick, last question.
Well, this is something I'm generally wondering, obviously, if you would have looked into things like number of correct repeats or something, there's basically no variance in the healthy controls, right? Because they all will manage to repeat perfectly. So going the reaction time route basically gives enough variance to do structure function relationship analysis. But I'm always kind of wondering to what extent probably a general like reaction time factor might play a role in these kind of healthy control studies. So do you have any idea on that, or any papers showing like to what degree, let's say, a general speed factor of reaction time might explain some of the variance of white metadata in general?
A difficult question. Not off the top of my head. Yeah, that is the short answer. Perhaps something pops up after this meeting, and I'll send you the but I.
That's fair.
Yeah.
Sure. Thanks.
Right, we're actually over time, so thank you so much for joining us today, Adi. Just a quick reminder, on Wednesday this week at 4 p.m. we have a CNS talk. I just put the details for you in the chat. I hope to see you there. And otherwise, I see you next Monday for another round of Neuroccino. Have an exciting week in science. Thanks, everyone. Bye.
Bye-bye.